So today what we want to do is we want to be able to find limits numerically. Okay, so on Friday what we did was it was graphically, right? Same idea, but numerically means we're going to do this with a table. And I actually taught you guys this last year in Honors Math 3, but we want to go back through this, okay? So back to the idea of what is a limit, okay? And this is really important you understand this. To know if this exists, okay? We have to find two limits. So we want to find the limit as x approaches 2 from the left of f of x. And instead of f of x, that could be replaced with the x squared minus 7. All right, now how can we do that? Okay, so we want to approach 2, right? But from the left. And what I would do is I'd start like 0.5 away from it on the left. So that'd be 2 minus 0.5, which would give you 1.5. So we're going to start this at 1.5. And then we're going to approach 2. So then 0.1 away to the left. So that'd be 2 minus 0.1, which would give you 1.9. And then 0.01 away. And what we're doing is we're getting really close. Okay, so 1.99. And then 1.999. Okay, and then 1.9999. And that's probably enough, okay, to figure out what's going on, okay? You could do one more and then you're getting super duper close, okay? But probably 0.0001 away is probably close enough to understand what's going on and see the behavior, okay? Now, we also need to find this limit. So we've got to figure out what this is. And we're going to use a graphing calculator to do this, okay? On Delta Math, you'll be able to plug these in directly into the table. But I want you to know how to do it with a graphing calculator, okay? And I'll show you how to do that in a second, okay? So we also want to do the limit as x approaches 2 from the right, okay? So from the right, I go 0.5 more than that, right? So that'd be 2.5. And then 0.1, which would be 0.1 to the right. So that'd be 2.1. And then 0.01 to the right. So that'd be 2.01. And all of these values are to the right of 2, okay? And then 0.001. So 2.001. And again, probably 4 decimal places is enough. So 2.0001. And what you're showing here is that x is getting close, and down here, super duper close, okay? Getting closer and closer to 2. And I should have written here f of x. Okay, so what I'm gonna do next is I'm gonna go to my graphing calculator, and what I'm going to do is show you how to enter this in the graphing calculator. And in all honesty, we did this last year, okay? So it's something you've already done. Okay, so what you want to do is you want to get into the table features, which is the table set. Okay, so to access that, we want to press second and then window. Okay, and then we want to go down here. It doesn't matter what the table start is, and it doesn't matter what the delta table is. I'm going to go down here on the independent, and I want to type in, or not type, highlight ask. Okay, all right, so if we do that, then we're going to go and we're going to press y equals. And my mode is off, so I'm going to go down. This is something you probably won't have to do. Okay. You want your mode to be on function. Okay. That's from BC Calculus. I haven't done that in a while. Okay. I haven't used this calculator in a while. Okay. So here we go. We want to go press y equals, and I'm going to clear out all of these functions. Okay, and we want to type in the function that we have. So x squared, and then minus 7. And then go back, and we want to go to our table. Not back, but we want to go to our table. So to get the table, it's in blue right here. So we have to press second and then graph to access the table. And then we're going to type in our values, okay? So we're going to type in 1.5, and then press enter, and then 1.9. And then press enter, and then 1.99, and press enter, and then 1.999, and we're getting closer and closer to 2, right? And then 1.9999. Okay, now again, I showed you guys this last year. If you go on top of it, it's really not -3. It's rounding to -3. Okay, but if you get far enough, okay, in this case 4 decimal places was enough, it will tell you what it's approaching. It's approaching -3, right? Okay, so let's go back. And you could put, it's fine on your table if you wrote -3 here. You don't have to write this. I'm just showing you it's not really -3. It's just rounding, okay? So let's go back to our table and record these values, okay? So recording this from our graphing calculator, we'd write -4.75 and then -3.39 for this one, and -3.04 and -3.004, and then finally right here -3. So this is getting closer. If you look at the function values or the y values, they're getting closer and closer to -3. Okay, let's go back to our graphing calculator and then let's put in this one. Okay, all right. So what you want to do is go back on top of the 1.5, and I'm just going to clear out all my entries, or delete. I should say delete. And go on top of the 1.5 and delete that one. Okay, so now I'm going to type in 2.5 and then 2.1 and then 2.01 and then 2.001 and then finally 2.0001. Okay, so now let's go back and we'll record these on our paper, okay? Okay, so this first one at 2.5, the function value is -0.75, and then -2.59, and then -2.96, and -2.996. And then this one is -3. It's not really, again, it's not -3, okay? It's just close. Okay, so again, this is equal to -3, right? So the left limit, okay, as x approaches 2 from the left and as x approaches 2 from the right, they agree, right? They're the same thing, which means because of this, right, we know that these two together, that would mean the limit as x approaches 2 of f of x is equal to -3, okay? Now, I want to show you some, let me slide that up just a little bit. Okay, I want to show you something because, right, something that we could have done on this particular problem, you're not always going to be able to, okay? And this is actually the next lesson that we're going to do in calculus is we could have plugged 2 into this, because what would happen if you plug 2 into the function? Well, what's 2 squared? 2 squared is 4, and then 4 minus 7 would be -3. So we could have gotten the limit on this particular problem by just plugging 2 into the function. And we'll talk more about that later, okay? But I want to show you, like, that's going to be the shortcut to this, is we can just plug it in, okay? And instead of writing f of x here, you could also write x squared minus 7, because that's what we're finding the limit of, okay? All right, so from here on out, I'm not going to be doing the graphing calculator. I'm not going to show you. I'm going to do it still, but I'm going to just use my handheld one and just write down the values so we can kind of get through this quickly, okay? Because it would be a long time if we went back and forth, okay, between the calculator and this, okay? Okay, so for this problem, our function is x squared minus 9 over x minus 3. And our limit, we want to find the limit as x approaches 3 of f of x. Now, in this case, if I try to do the direct substitution, that's what it's called, by putting 3 in here, I'm going to get an undefined value here, right? But we can still find the limit. So the f of 3 does not exist, okay? F of 3 does not exist. But I can still find this limit, and I can do that through tables, okay? All right, so we want to be to the left of 3, so that would, 0.5 away, so that'd be 2.5. And then we could get closer, 2.9, and then closer, 2.99, and then even closer, 2.999, and then even closer, 2.9999, and that's probably enough, okay? Now what we're doing is we're doing the limit as x approaches 3, but all of these values are to the left of 3, so that's why I'm going to put a little negative here of f of x. And what does this equal? So I'm going to put this into my calculator, all right, and we'll figure this out. Okay, at 2.5, the function value is 5.5. At 2.9, it's 5.9. And at 2.99, it's 5.99. At 2.999, it's 5.999. And at 2.9999, it's 5.9999. Okay? And if you look, we could go one more if you want to, but you can kind of see what's happening. The x values are approaching 3 from the left, and the function values are getting closer and closer and closer to a value of 6. Now, we don't say on this, we're not going to say, 6 above or 6 below, okay? It's just 6. It's just the number value it's approaching, and that would be 6, okay? And then over here, we want to do the limit as x approaches 3 from the right. So we want to be to the right. Let's start at 0.5 away, okay? So that'd be 3.5. And then 0.1 away, so that'd be 3.1. And those are both to the right of 3. And then 3.01. 3.001, and then 3.0001, okay? And that's, 4 decimal places like this. Again, it's probably close enough. Okay, so when I type this in, 3.5, I get 6.5. When I type in 3.1, I get 6.1. When I type in 3.01, I get 6.01. And 3.001, and I get 6.001. You can probably almost predict what's going to happen here. And then 3.0001, and that's 6.0001. And if you wanted to go one more entry, you could. And so the limit statement that we would write is the limit as x approaches 3 from the right of f of x is equal to 6. Now, those are an agreement, right? They're the same number, right? They both, from the left and from the right, they're both approaching the same value, y value or function value, which means that the limit as x approaches 3 of f of x is equal to 6. And I can't stress this enough, that you got to do both of these to figure this one out, okay? We have to do it graphically and numerically, okay? Now, there's going to be some techniques that I show you. You're not going to have to do a table or a graph, okay? But that's coming, okay? Right now, you need to show and understand that to show this, we have to figure out both of these and make sure they agree. There's exceptions to that, and I'll talk about them, but there's no exception right now, okay? We have to do these two one-sided limits. Okay. Okay, so for this problem, we have this function, and this is a piecewise function, and it's 4 minus x when x does not equal 2. So if x doesn't equal 2, we use this top piece, okay? But when x is exactly 2, it's 3. And that's the only time it's 3, so when x is 3. So this would be f of 2 is equal to 3, okay? All right, so, but can the limit be different than the function value? And yes, it can, and we're gonna see that here, okay? All right, so we want to approach 2, right? But we want to approach 2 from the one side of the limits, right? From the left side and from the right side, okay? So 0.5 to the left of 2 would be 1.5, and then 1.9, and then 1.99, and then 1.999, and then 1.9999, right? Four decimals, okay? We're 0.00001 to the left of it, okay? All right, so let me type these in. So 1.5 in my calculator gives us 2.5. 1.9 gives us 2.1. 1.99 gives us 2.01. 1.999, 3 nines, gives you 2.001. And then 1.9999 gives us 2.0001. And so the x's are getting closer and closer to 2, but all of these are to the left of 2. our function values or our y values, they look like they're getting really, really close to 2. So we'd write the limit as x approaches 2 from the left of our function f of x is equal to 2. And so remember, f of 2, though, is 3, right? So that's different, right? Okay, now let's go to the right. And to the right would be, let's go 0.5 to the right, so that'd be 2.5. And then 0.1 to the right, which would be 2.1. And then 0.01 to the right, so 2.01. 2.001, and then finally 2.0001. Okay, so let me type these in. So 2.5 gives us 1.5. 2.1 results in 1.9. 2.01 results in 1.99. 2.001, 1.999. And then 2.0001 and 1.9999. And this is telling us that the limit as x approaches 2, but the x's are approaching 2 from the positive side or from the right of f of x, and these y values are approaching the number 2. Okay, those are in agreement, right? So those are both the same, which means the limit exists, and the limit as x approaches 2 of f of x is equal to 2. Okay. All right, so that's example 3. Got a few more examples to do. I'm going to start getting into ones in just a little bit that these are not going to agree. Okay, and so we'll just then if these don't agree, then this limit doesn't exist. Okay, and that's going to be important here. All right. All right, so something I want to point out is in calculus. Okay, we want to make sure our graphing calculators. Okay, when we're dealing with trig functions, it has to be in radians, okay? So when you have your graphing calculator, okay, I have mine up right now, okay? You want to look at this and make sure at the top it says radians, okay? All of our rules that we're going to have for calculus, okay, they are much more complicated, and it makes calculus a lot harder if the angle we're measuring is in degrees. So we want it in radians, okay? There's a rare occasion where we'll use degrees. It's really rare. It's in one type of problem that we'll talk about later on, okay? But 99.99% of the time, we want it to be in radians, okay? So just make sure, all right? So for this problem, we're gonna type in y equals, and I'm gonna type in sine x over x, okay? And then what we wanna do is we wanna find the limit as x approaches 0. So we wanna get closer to 0, okay? So if we wanna approach 0, I would go subtract from this value, subtract 0.5 to get on the left-hand side. So 0 minus 0.5 would be negative 0.5. And then negative, and then 0.1 to the left. So we want to take it and subtract, okay? And that'd be negative 0.1 and negative 0.01 and negative 0.001 and negative 0.0001, okay? And so I'm going to go to my table and figure out what these are. So at negative 0.5, I got 0.9589. And then negative 0.1, and I get 0.9983. This is going to be an important limit that we're doing right now. You just don't know that yet, okay? And then negative 0.01. And automatically it's giving us 1, okay? So I'm going to highlight it. It's really not 1, okay? If you look at it, 0.9999, okay? It's just rounding it to 1. I'm actually, just to show you, this is 0.99998. And so it gets close to 1 pretty quickly, okay? And then we want to type in negative 0.001. And it's getting closer to 1, and then even this one, negative 0.0001. I just want you to understand that it's really not 1, okay? It's just a lot of 9s after the decimal, okay? All right? So it's 1, okay? So what are we doing? We're taking the limit, And we're making, by making this table, we're making x get closer and closer to 0 from the left of f of x. And by looking at this, the value is 1. And remember, we couldn't find f of 0 because that would mean we're dividing by 0 here, because x would have to be 0. Okay? Now we want to be 0.5 to the right. So that'd be 0.5, 0.1, 0.01, 0.001, and 0.0001. This one's going to it's going to be like this. It's going to get close to 1 really fast. Okay? So 0.5 was 0.9589. So there's some symmetry here, right? Because it's the same value. Okay, and then 0.1 is 0.9983. And then 0.01 is, it's rounding to 1, but it's really this. It's 0.99998. Okay, and then 0.001, and it's rounding to 1, and this one's rounding to 1. So we have the limit as x approaches 0 from the right of f of x, and it equals 1. And those two are in agreement, right? They're the left limit as x approaches 0 and the limit as x approaches 0 from the right, both are equal to 1. That means that the limit as x approaches 0 of f of x is equal to 1. So this is how you could estimate a limit, okay? If you don't know how to do it, this is a go-to of like how to figure it out, okay? I didn't give you the graph, but you have to, somehow you have to figure out a limit, okay? This is a problem that there is no way we can do it until, it's honestly probably January. We're not gonna be able to do this problem. We're not gonna be able to actually find this limit algebraically or using calculus until January. It's going to take that long to learn a lot more before we can do it. So the only way to do this problem, I'm going to tell you right now, is to make a table and figure it out, because you can tell definitely what's going on. Okay, they're both getting closer to 1. Okay, let's go to the next problem. Okay, so here's a problem where we have a function. It's the absolute value of x minus 5 over x minus 5. Okay. And so we want to find the limit as x approaches 5. And I wrote the actual function here. I didn't write, you could write f of x because f of x and this are the same thing. So because these are equal, right here you could write f of x, or you could put f of x, what f of x is equal to, okay? All right. So right here, we want to approach 5 from the left because we got to look at the one-sided limits to determine this. So the limit as x approaches 5 from the left of f of x, and we're also want to do over here the limit as x approaches 5 from the right of f of x. You know, I'm always doing the right side on this. It doesn't matter though, guys. Let me tell you, if you had this one over here and this one over here, it's fine. It doesn't matter. You just have to find these two one-sided limits. Which one you find first does not matter, okay? So if we want to be to the left of 5, that would be something like 4.5. And then 4.9, and then 4.99, and then 4.999, and then 4.9999. Okay, and for over here, it'd be 5.5, 5.1, 5.01. It's powers of 10 that we're adding to this, okay? 5.01, 001, and then 5.0001, okay? Now, you may have forgotten, so I'm gonna show you how to do this, okay? How do you put this in your calculator? How do you find absolute value, okay? So we want the fraction bar. Let me clear this out. Okay, without going to the other computer screen. Okay, let me try to get that glare off, okay. So one thing you can do is we want to go to the fraction bar, okay, and then where's absolute value, okay? So remember these function values, right? These f values, okay, so you can press alpha, window, and it's the first one, okay? That's one way to get absolute value, okay? And then we want to type in x minus 5, and then denominator x minus 5. Okay, and now I'm going to go to my table and put these values in. Okay, so 4.5 gives you -1. 4.9, -1. Exactly -1. If you go on top of it, it's exactly -1. 4.99, -1. 4.999, -1. And I picked this problem to do on purpose because these are all the same. Okay, now it's not approaching like the traditional sense of approaching, but it's always the same, right? So that means if you approach 5 from the left, the function value is always the same, and it's always -1. Okay, how about from the right? So let's put in 5.5. That comes out to be 1. 5.1, that turns out to be 1. 5.01, that turns out to be 1. 1. They're always 1. So this one, the limit as x approaches 5 from the right of f of x, it's always the same and it's always 1. So that means as x approaches 5 from the right, it's 1. But what if we try to actually put 5 in? Okay. And I'm going to show you what happens. I'm going to delete all the ones I have. Look what happens when we try to put 5 in. It gives us an error. Why? Because it's undefined, because you're trying to divide by 0. Okay. So the left-handed limit is -1 and the right-handed limit is +1. Those are not in agreement. So we would say the limit as x approaches 5 of f of x does not exist. Why? Because for this limit to exist, the left-hand limit and the right-hand limit have to be the same. You have to be approaching it from both sides, and it has to be approaching the same value, okay? Even though the function value is different, okay? As long as it's approaching, as long as these tables give you the same value, you'd be fine, okay? But it's not in this case. All right, so let's do the next one. So once again, we're dealing with a trig function, right? F of x equals tan x. Find the limit as x approaches -pi/2 of tan x, which would be the same as saying the limit as x approaches -2 of pi/2 of f of x, okay? Now, I'm going to do this a little bit differently, okay? Because this is kind of a number. It's not a nice number like 3 or something, okay? So what I'm going to do is to go to the left of this, I'm going to always subtract. And to go to the right, I'm going to add, okay? So I'm actually going to type in and write in, and I'm going to be 0.5 to the left of this. So that would be -pi/2 minus 0.5. Okay, now I don't care if that's a number value, okay? That's to the left of -pi/2, okay? And then I'm going to take -pi/2, and I'm going to get closer to it, but I'm still going to be on the left-hand side. So what I would do is take -pi/2 and minus 0.1. I don't really care what the number here is, okay? It's that it's getting closer and closer to -pi/2 from the left-hand side. So then -pi/2 minus 0.01, still getting closer. And then -pi/2 minus 0.001, and -pi/2 minus 0.0001. And we're going to see what are these values doing, okay? All right? Okay, so I'm going to type in -pi/2. You have to put in pi/2, and then minus 0.5. And you need to make sure, again, you need to make sure you're in radians, okay? And you get 1.8305. Okay, what's important here is x is getting closer and closer to -pi/2 from the left-hand side, okay? And then -pi/2 minus 0.1. And you get 9.9666. And then -pi/2 minus 0.01. And you get 99.997. And then -pi/2, -pi/2 minus 0.001. And it's rounding, to 1,000. It's actually 999.999, okay? But the calculator is giving me 1,000. Okay, and then so let's get even closer. So negative pi divided by 2, that's negative pi over 2, minus 0.0001. And then for this one, we don't get 1,000, we actually get 10,000. So can you see what happens? Our x's are getting closer and closer to negative pi over 2 from the left. So we would write the limit as x is approaching negative pi over 2 from the left of f of x, or tan x. And what is this equaling? Well, it's actually not equaling a value, right? It's actually just exploding in a positive way. So we write infinity. Now, writing infinity also means does not exist, okay? So when you write infinity, that's telling me what the y values are doing, but it's not the value of the limit. It's still that limit does not exist, okay? Now, how do we do the same thing, but to the right? So we would have to take negative pi over 2. And since I'm subtracting to go to the left, I'm going to need to add to go to the right. So plus 0.5, and then negative pi over 2 plus 0.1. Isn't that what we did really on all the rest? It's just we got a numeric value here, okay? And then here, negative pi over 2 plus 0.01, and then negative pi over 2 plus 0.001, and then negative pi over 2 plus 0.0001, okay? And so let me put those in. So negative pi over 2 plus 0.5, and that gives you negative 1.83. And then negative pi over 2, and then plus 0.1, and that gives you negative 9.967. And then negative pi over 2 plus 0.01. And you get negative, I got negative 100. It's rounding, okay? It's not really negative 100, it's rounding to negative 100. And then negative pi divided by 2, and then plus 0.001. And I got negative 1,000. And again, it's rounding to that, okay? And then negative pi over 2 plus 0.0001. And you got negative 10,000. Okay, so this is taking the limit as x is approaching negative pi over 2. But because we're adding, right, that's going to be to the right of negative pi over 2 of f of x. And this one's equal to negative infinity. And whenever a limit, any type of limit is equal to infinity or negative infinity, it means it does not exist. So again, this is does not exist, okay? So from these two, we could say the limit as x approaches negative pi over 2 of f of x does not exist, okay? All right, one more problem and we're done with this, okay? Okay, so for this problem, it's different. You may be thinking, wait, we already did this problem. No, we didn't, okay? The other one was sine of x over x, where this is sine of 1 over x, okay? There's a difference between the two. The trig function, we're taking the trig function of 1 over x, the reciprocal function, okay? And what we're doing is we're finding the limit as x approaches 0 of sine of 1 over x, okay? So we want to be to the left of this. So that'd be 0 you could do it like I just did, 0 minus 0.5, right? So that put you at negative 0.5. And then negative 0.1. And then negative 0.01. And then negative 0.001. And negative 0.0001. Okay? And so we're going to type those in and see what we get. So negative 0.5. And you get negative 0.909. Once again, I need to say this because we're dealing with trig functions, your calculator needs to be in radians, okay? I'm going to say that a lot because I don't want the mistake of you had it in degrees, okay? So negative 0.1, and you get a positive 0.544. And then negative 0.01, and you get 0.5064. And then negative 0.001, and all of a sudden now you're at negative 0.827. And let's do this last one, negative 0.0001. And it's up all of a sudden positive again, right? 0.3056, okay? Now, this is not approaching infinity. These aren't getting bigger, either in a positive way or negative way. And actually, they're jumping around, right? Sometimes they're negative, sometimes they're positive, right? So this limit, and what we did here is we're finding the limit as x approaches 0. And how are we approaching 0? We're approaching 0 from values that were smaller, right? So that'd be to the left of f of x. And we would say this does not exist because it is not getting closer and closer to a numeric value. It's bouncing around. Here it's negative, here it's positive. These are kind of close, right? But then all of a sudden you're at negative 0.8, and then all of a sudden you're at 0.3. It's bouncing around, okay? All right, and then this last one we want to do is let's do 0.5, and then 0.1, and then 0.01, and 0.001, and 0.0001. Okay, so we type in 0.5 and I get 0.9093. At 0.1, I get negative 0.544. At 0.01, I get negative 0.506. 0.001 is 0.8269. And then 0.0001, and all of a sudden it's negative 0.306. Once again, it's bouncing around between positive, negative, negative, positive, negative, right? It's not getting closer and closer to any one value, okay? And you'll see it, like you'll start seeing like it gets closer and closer, like the decimal, like you'll get 2.9, 2.99, like we were seeing earlier, okay? All right. So this would be, we would write the limit as x approaches 0 to the right of f of x does not exist. And so because they have to be in agreement and neither one of them exists, so that means the limit as x approaches 0 of f of x does not exist. Okay? And that's how you do it numerically, okay? It's something I taught you last year, okay? And it was to speed things up. So when I taught this year, it'd go a little bit smoother and a little bit easier, okay? And, you know, the next lesson in calculus is going to be, I think, fairly easy, okay? And then we're going to start getting to some algebra. Like, how do you do these without a table? Because some of these that we did today, you can actually do without a table. And I'll show you how to do that in a couple days, okay? All right, that's it, guys.